If you take a closer look at the block available for the brick solid, you see that it has one port, and that port is a connection to the centroid of this brick solid. The centroid is in the middle of a solid, to put it simply, kind of the. So if I connect this R port to a revolute joint or whatever kind of joint, the centroid of the brick solid would be connected to that whatever joint that I'm connecting it to. But if you remember our example, we are connecting the leftmost end of the rod to a revolute joint, and if I am to connect the leftmost end of the leftmost end of the rod to the revolute joint, I need a reference to that leftmost end. And to obtain a reference to that leftmost end, I'll be obtaining a rigid body transform block. So I can either connect the B to R ports or the F and R ports together. Based on whatever I connect, I need to inspect the documentations and figure out what I need to specify. But either of these connections is fine. I'll connect F and R together. So that's basically what you need to do in order to specify the matrix that you will be requiring a cuboidal block, and you will be requiring a reference to some point other than the centroid of that block solid. Now what we have left to do is we have to specify the geometry and the mass of this solid, and then we have to specify at to which exact point of this block that we need a reference to. Let's specify the geometry and the mass first. So upon double clicking it, should bring up the pop-up pop-up box. And the geometry, I can specify the length, width, and height. So it would be the first value that I specify would be the dimension in the x direction, the second in the y direction, and the third in the z direction. So since I'll specify having a length in the x direction, and since we're dealing with meters, and as I can remember, our length for previous cases was 0.2, I'll keeping it at 0.2 as well. In our previous attempts at solving this, height and width of the model really didn't matter. So I'll give it some arbitrary but kind of practical value. So that's it with regards to the geometry. We're going to specify it using primitives. By primitives, I mean how long some dimension is. And now we can specify the inertia. I'm going to specify it based on mass, not density. First, I'll specify it to 0, and you can change it later on based on your requirements of the system that we are going to study. This is what you'll be seeing. 0.2 meters long in x direction, 1 millimeter wide and 1 millimeter thick. So let's, doesn't really matter, I'll leave it at 1. Right. Okay, so our centroid would be at some point over here, and we need to make a reference to the leftmost point, and that leftmost point is 0.1 meters in negative x direction. Our centroid is in the extreme middle. By that I mean it should be the x coordinate, y coordinate and z coordinate of the centroid is 0, and the whole geometry extends symmetrically from the centroid in all three directions. If the centroid is in the middle with regards to the x-axis, it is, and the reference that we want should be zero point 0.1 meters away from the centroid in the negative x direction. So we'll make that specification in the rigid transform block. So we'll open it up, and we need to specify a translation between coordinate systems. It's a translation, not a rotation, and the method would be Cartesian or standard axis. If I choose Cartesian, I think it will use the global coordinate system, and I can use, if I use the standard axis, it will still be somewhat of a Cartesian system, but the reference would be with regards to the frames or coordinate systems that are connected to the spots. So I'll choose the standard axis, and I need to specify the offsets and along which axis the offset is. So few minutes ago we figured out that the offset should be along the x-axis, and it should be 0.1 meters. It should be along the negative x-axis of the brick solid. But this rigid transform specifies, if I specify it as positive x and negative x and 0 point as we thought we'll be requiring, that would mean the port F would be 0 0.1 meters in the negative direction from port B. Now port B is actually the reference point that we want, and it is at the extreme left end of the rod. So if port B is at the extreme length, it should be 0.1 meters in the negative 0.1 meters in negative x direction, and that's B expressed relative to relative to the centroid, and port F and port R are both representative of the centroid. That's B relative to the centroid, but this rigid transform block specifies the point F relative to point B. So what we need to specify here is the opposite of what we really want. So that's why I'm choosing S. When I choose a positive x and an offset of 0.1 meters, MathWorks will know that port F will be 0.1 meters away in the positive x direction